Okay, welcome to section 7.2. The last recording I didn't capture any sound, so I am hoping and praying that this one works. Section 7.2, we were talking about proportions and the properties of proportions. So yesterday we started out a little bit with proportions. We talked about ratios, setting up proportions. Today we're going to continue on with that, and we are going to use these properties to write equivalent proportions. So some of these examples will just be practice writing these and rearranging them and manipulating them, and eventually we'll be able to actually solve some problems by writing proportions. There's a lot of applications of proportions. Like, proportions are one of the most practical math skills you can learn, especially in chemistry. You all will take chemistry at some point during your high school career. You will need to use proportions and ratios all the time. So while you're learning this now again in geometry, and you've dealt with proportions probably in the past a little bit, really put good effort into learning this because it's going to keep coming back, okay? So strive to do your best now. There's also a lot of other applications with engineering, with construction and creating buildings. Proportions are huge in the art world. So proportions really are everywhere, which is really cool. So we are going to talk about some properties first. All right, our first property, and I'm going to try to color code a little bit here. We'll see how it goes. I'm going to start with this proportion right here. A over B equals C over D. And I can say that that's equivalent to writing the reciprocals for both of these. So I'm going to flip-flop A and B, and I'm going to flip-flop D and C. I am always allowed to, in a proportion, write the reciprocal of both. And let's see this with some numbers. If I say 2 over 3 is equal to 4 over 6, hopefully we'll all agree that's true. If I apply this property, then I would rearrange this and get 3 over 2 equals 6 over 4. Would we also say that that is true? Hopefully, yes, right? If I simplified 6 over 4, it would just get me right back to 3 over 2. So I am not saying that A over B equals B over A. Like, I'm not saying that the reciprocal equals the original, but I am saying that I'm writing an equivalent expression, something where the cross products are the same. So this one, 2 times 6 equals 3 times 4. That's going to be 12 equals 12. Cool, that makes sense. Over here, if you used your cross products method, you would also get 12 over 12 equals 12. Another true statement, right? So that's all we mean by equivalent expression. Your cross products will get you something that is also true for both of those. All right, our next property has to do with the means. So yesterday we talked about how B and C, these values right here, we call them the means. Property number 2 says, hey, just flip-flop them. So I'm going to swap B and C over here. I'm just swapping the means. And I'm going to color coordinate it again. So this is what it would look like with numbers. I'm again going to start with 2 over 3 equals 4 over 6. If I apply this property, then I'm going to flip-flop the 4 and the 3. So I'm going to get 2 over 4 equals 3 over 6, another true statement, right? So again, I know that 2 over 3 is not equal to 2 over 4. That's not what I'm saying here. I'm just saying if you use this property, you will end up getting something true, another true statement here. All right, the last one we're going to talk about has to deal with our denominators. So for this one, when I apply this property, I'm just going to add the denominator to the numerator. So over here, then I would have C plus D over D. What this would look like, again, with our 2 over 3 equals 4 over 6, I would have 2 plus 3 over 3 equals 4 plus 6 over 6. If I simplified that a bit, I would get 5 over 3 equals 10 over 6. Still a true statement, okay? So that still works out. This is an equivalent form. So these are 3 proportion properties. First one says, hey, your reciprocals are also equal. Second one says, swap the means. Third one says, you can add the denominator to the numerator on both sides of that equal sign. So let's practice with these a little bit. They're giving us this proportion here, 3 over x equals 4 over y. Using property 1, how could I rearrange this? Hopefully you're trying it out. Well, I'm just going to set my reciprocals equal to each other. So x over 3 equals y over 4. That is my first property in use. What is number 2? That one, I am just flip-flopping the means. So again, starting with our original up here, my means are x and 4. When I switch them, that gives me 3 over 4 equals x over y. So again, for this problem, I'm not solving for anything. We are just rearranging and practicing using those properties. Try out the last one. The last one says I can add the denominator to the top, and that will also give me an equivalent proportion. So I will be adding y to 4, and I will be adding x to 3. There you go. So that's just ways that you can rearrange based on these properties. Let's actually try to solve for something now. So in example 2 down here, and again, pause anywhere in the video and stop. I'm just recording it at a certain pace, but you can pause it and take notes as you go. Here they're giving us a diagram, and they're telling us that x over 6 equals y over 7. What ratio completes the equivalent proportion? How would I fill in these boxes? Justify your answer. So there's two ways you could go about this. You could use your cross products method, or we could just use property 2 here, right? So using your cross products method, that would take some work. I have x over 6 equals y over 7. I want to rearrange this to get x over y. First thing I would do would be divide both sides by y. So when I do that, divide both sides by y, let me go back. I'm going to start with x over 6 equals y over 7. Cross products, there we go, I just skipped a step. Cross products would give me 7x equals 6y. I would like to rearrange this to get x over y. So now I would like to divide both sides by y. That gives me 7x over y equals 6, because the y's would cancel out. Then I would divide both sides by 7, and that would give me x over y equals 6 over 7. All right, so this is the answer we're looking for to fill in those two empty boxes. X over y equals 6 over 7. But property 2, way stinking quicker. Okay, property 2 just says swap the means. If I want to figure out what x over y is, well, let me swap the means, and it'll tell me that it's 6 over 7. Okay, so you can use either method, but just showing you these properties are helpful. Learn the properties, they save you a lot of time. This is kind of a little bit of a hint at where we're going. We eventually will talk about similar triangles, and you will be dealing with some problems like this, and you'll need to set up some proportions and eventually solve for stuff. So kind of a little hint at what is to come. All right, let's try this real life example. Word problems don't have to be hard. Application problems don't have to be hard. We just need to break it down. Our first step is always to try to understand what is going on. Maybe you want to draw a diagram. I don't know. You won't have to do this for every problem. I'm just trying to give you a tool, something that you can use for other applications. Maybe it would be helpful for those. So they're telling me that 5 miles here corresponds to 2 inches. Then they're asking how many miles corresponds to 7 inches. Well, if I kept adding 2 inches plus 2 inches plus 2 inches, all right, I'm up to 6. And then if I add another 2 inches, I'm up to 8. So 7 is going to be somewhere in between 6 and 8, right? Common sense. Well, how many miles would that be? Well, that would have to be 5 plus 5 plus 5. It's going to have to be somewhere between 5 and 15, or excuse me, somewhere between 15 and 20 miles. That's what we're seeing in our little diagram over here. 5 miles corresponds to 2 inches. Step 2, that step was just, hey, what's happening? Understand what's going on. So now I need to translate this into a proportion. What I'm going to do for this one is I'm going to keep miles on the top, and I'm going to keep inches on the bottom. We will see in this problem and the coming problems, there's a lot of ways that you can set up these properties, because these proportions, because like those properties say, there's a bunch of equivalent proportions that you can use here. And then when you use your cross products to solve, you'll get the same answer. So I'm going to say 5 miles corresponds to 2 inches. How many miles? The thing that I'm trying to solve for, that's going to be x, corresponds to 7. Now I can go ahead to step 3. I can solve this using my butterfly method. I'm going to have 5 times 7 equals 2 times x. So 5 times 7 equals 2 times x. 35 equals 2x. Divide both sides by 2. That's going to give us x equals 17.5 miles. Our final little step here would be to check your answer. Does this work with what we guessed? We said I would be somewhere between 15 and 20 miles. Yep, perfect. 17.5 is exactly between 15 and 20 miles. So again, you will not break every problem down into these 4 exact steps. You will not draw a diagram for every problem, but sometimes it's going to be helpful. Use the tool if it's helpful. Let's keep on going here, folks. Here is a medical example. So I don't know if any of you are considering being nurses, but if you're a nurse or a doctor, you would hear this term CC a lot. Maybe you've heard that in TV shows. Maybe you guys have been to the hospital. I don't know. Someone needs, 20 cc's of some medication. CC stands for cubic centimeters. It's a way to measure antibiotics. It's a way to measure medication. It's basically measuring liquid, 4 cc's. So here they're saying I need 4 cc's for every 25 pounds. If I'm dealing with a 140-pound woman, what dose would she need? So they already drew us our diagram over here. Step 1, understand, maybe draw a diagram. For every 25 pounds, she needs 4 cc's. So I'm going to try to add up pounds until I get to 140. So 25 plus 25 plus 25 plus 25 plus 25, that gives me 125, plus another 15 gets me 140. So I know she's going to need at least 1, 2, 3, 4, 5 times 4 cc's, at least 20 cc's, but a little bit more. So they already gave us that diagram here. That's step number 1. Step number 2, translate. How can I create a proportion over here? There's 2 different ways that you could create this. You could keep your cc's on top, and you could keep your pounds on the bottom. So I know that 4 cc's corresponds to 25 pounds. That's going to be equal to how many cc's for 140 pounds. The other way you could set this up is by keeping the cc's together in a column and the pounds together in a column. So I know that 4 cc's corresponds to 25 pounds. How many cc's corresponds to 140 pounds. All we did here was really apply that second property, right? The only difference between this proportion and this proportion is my means have been swapped. So each of you might set these up differently. I tend to find that different brains just set up proportions differently, and that's cool. You guys will still get the same answer. Just make sure you're being consistent and you're keeping the same unit together either in a column or a row, and you're keeping things that correspond together. So in this case, 4 and 25, either in a column or a row. All right, if I solve either one of these using my butterfly method, I'm going to get 4 times 140 equals 25 times x. 4 times 140 is 560. Let's divide by 25. Maybe take out your calculators or do the long division here. We're going to end up with x equals 22.4 cubic centimeters. Your last step is number 4. We're just going to kind of check this real quick. Is that what we expected? Yeah, I expected something a little bit over 20 cc's, probably less than 25 cc's. That's exactly what our answer is giving us. All right, we're going to keep on applying proportions. The next one is a map. This one is going to really connect with your kite project because your blueprint is kind of going to be a map for your kite. It is going to have a scaling factor, which we'll talk about those tomorrow. So yeah, this one is going to kind of connect with your blueprint. Start thinking about your kite designs. Here's my beautiful map of Italy. I know that 1 centimeter corresponds to 30 kilometers. Find out how far apart Milan and Rome are if their corresponding points are 15 centimeters apart. So 1 centimeter corresponds to 30 kilometers. They're 15 centimeters apart. How far apart are they in kilometers? Use your cross products. 1 times x is x. 30 times 15 is 450. Boom. That is your answer. 450 kilometers is what we are looking for. Take a second and see if you can solve part B. Pause the video and then come back to see if you got the same thing. How many of you are actually going to pause the video? Probably not many, so I'm going to keep talking. Solve this problem while I'm talking. On the map, a small Italian village is located 0.4 centimeters from the Mediterranean Sea. Find the actual distance. So I know that 1 corresponds to 30. They're saying we are 0.4 centimeters away. I'm going to use y here because we already used x. Solve for y. And that's going to tell us how many kilometers apart these are. What is 30 times 0.4? It's going to give us 12 kilometers. And that would be your answer for part B. Folks, you only have one problem left. Let's get into this one. So this one is almost like a full paragraph here. But break it down, right? Step 1, understand what the heck is going on here. I know that a certain mosquito control, like a spray here, it's a liquid, it has 30 ounces of pesticide mixed with 100 ounces of water. The mixture is sprayed on roadsides to control the mosquitoes. If one mixture of water with pesticide is 3 ounces of pesticide plus 100 ounces of water, if that one mixture can treat 150 feet of roadway, then how many ounces of just the pesticide are needed to treat 1 mile? Thankfully, I'm giving you guys the mile to feet conversion. Maybe you already have that memorized. So instead of dealing with 1 mile, I can just say, hey, it's 5,280 feet. All right. So how'd you guys set up this proportion? What do we think? One mixture of the water with this pesticide can treat 150 roadways. So 3 ounces would be needed to treat 150 feet of roadway. How many ounces then would I need to treat 1 mile, which is the equivalent of 5,280 feet? Well, there's 2 ways that you can set up your proportion here. I can say 3 ounces corresponds to 150. So how many ounces corresponds to 5,280? Or you can keep your, so for this one, for example, I'm keeping the ounces on top and I'm keeping the feet on the bottom. Or you could say, hey, I know that 3 corresponds to 150. X is going to correspond to 5,280. Okay, both of these work. This one is keeping the ounces in the same column and the feet in the same column. If you solve either one of these, this is now heading to step 3, solve. I'm going to have 3 times 5,280 equals 150x. Take a second and see if you can solve this one out. So grab your calculators. What is 3 times 5,280? That's going to give us 15,840 equals 150x. I want to divide both sides by 150. We are going to end up with x equals 105.6. Check yourself, see if you're getting the same answer here. And then our last step 4, check. Does this kind of make sense? Well, what's the difference between 150 feet and 1 mile? Well, I'm going to just say, what's 5,280 divided by 150? I'm getting 35.2. So I know that I'm going to need at least 35 times the amount of pesticides, right? If I multiply 35 times 3, that's giving me 105. So yes, this answer works great. I have a little bit more than 35 times that amount of pesticide. I need 105.6 ounces. Good job, folks. The only thing that you need in your comp books from this section, there's really not much for comp books, is the purple box on page 300. Please do not put helpful hints. Do not write anything from the brown boxes. That is not allowed. I've only seen that pop up a time or two, but especially as I'm flipping through these sections over here, you have a couple definitions. You are welcome to write definitions, but the things in the tan or brown boxes, the helpful hints, do not put those in. Those are not allowed. Only the theorems in the green boxes, the occasional purple box. So I'm letting you know the purple box on page 300, and the definitions, things highlighted in yellow. Those are the only things that are allowed in your comp notes. So feel free to get working on those and continue on with the rest of the subplans.